So example 7 refers to the same projects that we considered in example 7. And I demonstrated for you how to find the expected duration of each path and its standard deviation. Now you know very well why I was looking for these two values for every path. All right, so we did that, and these are the answers. And the first question in example 8 is identify the critical path. Now you may wonder that under the uncertainty in the activities durations, what shall I take? Remember, we are looking only for the path, right? We're looking for the critical path. So for us, we have no other option but to look for the expected value. Remember, this is t of the path. This is the expected value of the path, which was found by summing up the expected values of the durations of the activities. Okay, so as we did in the case of deterministic durations, when we designated the critical path as the path that has the longest duration, here it's the same, but the critical path is the path that has the longest expected duration. Nothing changed except what's our reference? Is it duration or the expected duration? Here it's the expected duration. So we can compare. Here we have an expected duration of 10, 16 here, and 13.5. So obviously this is our critical path, okay, which is path D, E, and F. And now in the next slides, we're going to continue to answer more questions. So remember, DEF was our critical path. Why it's important? Because in order to answer the questions about the probability of the completion of the project, we have to answer about the probability of the completion of the critical path, which is DEF. It has an expected value of 16 and a standard deviation of 1. Okay, question B is, what's the probability that the project is completion within 17 weeks? So to answer this question and to make my notation much simpler, let me just set X to be the duration of the critical path. Remember, which was DEF. So what do I know about X? Okay, so X, the duration of the critical path, is a variable. It has an expected value, it has a variance. And also we made an assumption about that. Remember, what is it? That the duration of the path is normally distributed. So that expected duration, this is a mu, and standard deviation is sigma of a normally distributed variable, right? So I defined X as the duration, and I can then say that X, remember we used that notation many times in our classes, is normally distributed with a mean of 16 and standard deviation of 1. Okay, so now I can rewrite the question as the project to be complete, the probability that the project is completed within 17 weeks is equal to P of X less or equal than 17. Why this is important? Because once you reach this point, now I will bring you back to exercises that you were doing when you took your QBA class, managerial statistics, where you learned that when a variable X has a normal distribution with a mean of mu and standard deviation of sigma, you can answer any question similar to that question, right? So let's draw the normal distribution curve to make it visual. I will make the solution for you visual, guys. So this is X. Okay, it has a normal distribution, so this is my axis, right? So, which means that this value of X is smaller than this value, which is smaller than that, and it has a mean of 16, which is in the middle of your curve. Okay, now I'm looking for X equals 17, and I want the probability that X is less or equal than 17. So remember, the probability, this is a PDF, probability density function. So to find this probability, I'm looking for the area under the curve, all right? And I will call this area A1, which then this will allow me, this new notation, to write this, that P of X less or equal than 17 is A1, right? So far, you're very familiar with this now procedure. Now, how to find A1? A1 is my final answer, by the way. Okay, I need to find this area. We learned in QBA that for any variable of x, it's not easy then to find the areas, right? So what we do, we refer to the unit normal distribution z. So here we go. I'm going to show you the z distribution underneath the x distribution. And we have learned that for any value of x, I can find a corresponding value of z, and I will call it z17. Why? Because I'm just saying that, you see, this is why I projected that vertical line from where it was hitting the x distribution into where it hits the z distribution, and it's not by coincidence that I'm calling it z17. Z17 will be the value of z that correspond to x equal to 17. Okay, why this is important? Because for this Z17, the area here below that Z17 will be equal to A1, the same A1, which is this one. All right, so I need to find this A1, which means I need to find this A1, and to find this A1 here, I will find this Z. How to find this Z? It's easy, right? Z and x are related using the general equation, which is z equal x minus mu over sigma. Okay, this is a basic equation that we have used in statistics. So, which means that for every value of x that belongs to a normal distribution with a mean of mu and standard deviation of sigma, okay, I can find its corresponding z value, where z is a variable that is normally distributed, and we call it the unit variable that has a normal distribution, and the mean and the standard deviation of my x, my variable, I use them here in the conversion equation. So you can guess that I can get z17. Why? Because x is known, which is 17 I'm looking for. Mu is known, sigma is known, so I can find z17. So z17 is equal to 1. All right, that's good. So this is equal to 1. I found it to be equal to 1. Now, how can I get A1? Because once I get A1, this will be that A1, and this will answer my question. So, how to do that? I will go to the Z table. This is an extract of your Z table. The question is, what's the probability that Z is less or equal than 1? Here is 1. So this is my probability. Here we go. So I can write that from the Z table, I learned that P of Z less or equal than 1 is 84.13%, which is my A1, which means P of X less or equal than 17 is 0.8413, right? And then I can make my final statement about the probability of the project completion. Here we go. It's 0.8413. Okay, I hope that was clear. We're going to answer more questions, which hopefully will reinforce some of the concepts that we have used in this slide. Okay, in part C, very similar to part B. So it's a very good practice for you. If you want, I really strongly to do that. If you really understood what we did in the previous slide, why don't you stop the video? Now you have the question. Try to do it on your own, and then restart the video and compare your results. So here the question, similar to the first one, but we are interested to know what's the probability that we can complete the project within 14 weeks this time. Okay, we are going to use exactly the same approach, same concepts. So again, I will name x the duration of the critical path, which means, and x then is, I can define it as a normally distributed with a mean of 16, standard deviation of 1. So I can write my question in a probability statement, and I can convert it into a probability statement with x. Now I go back to my curve, and I locate 14 somewhere here. So I'm looking for this area A2. Also, I'm going to and I will replace my probability statement where I write this is A2. Okay, and now I'm going to refer to my Z value. So I find for x equal 14, what is its corresponding Z value? I will call it Z14, as you noticed here, Z14. And for Z14, I find this area, which is the same as above area, okay, which is A2. So the question here, what is it Z14, or find Z14 and then find A2, and this A2 will be the same for X. Okay, how to find Z14? Also the same concept. So we now find Z14 to be 14 minus 16, so X minus mu over sigma minus 2. So I'm going to show you also an extract from the Z table where I can locate Z equal to minus 2. So here we go. You can see Z equal to minus 2 in the last rows. Here we go. This is Z minus 2. It's exactly minus 2, so you look at the first column, so which is 0.0228. Okay, so from the Z table I can write this, that P of Z less or equal than minus 2 is 0.0228, which is my A2, right, as we did here. And this A2 is nothing but that A2, which means I can now write this. P of X less or equal than 14 is that one, which is 2.28%. And I can now present my final answer in terms of the completion time of the project. And it is 2.28%. Okay, so I believe this should be now even easier for you than part B.